from pressure pushing in on all sides, but they push a little bit harder the deeper that you are, which is why it hurts more to be the bottom guy in a dog pile, or it hurts your ears more the deeper you dive in the pool. And this makes sense because the deeper you dive, the more water there is above you pushing down. And if you add up the size and direction of all those arrows, a bunch of stuff cancels out, and you're left with one net force pointing upwards. That is the buoyancy force. And if your buoyancy force happens to be greater than your force from gravity, you float. And if your buoyancy force happens to be less than the force from gravity, you sink. Now, we usually think of buoyancy with water, but you could think of things like helium balloons being buoyant in our atmosphere. So here's a trick question. Which of these has a higher buoyancy force? It's actually the rubber ball. Buoyancy force has nothing to do with the density of the object, just the volume. So since the rubber ball takes up more space, it has a higher buoyancy force. But, you might object, then why does the rubber ball sink and the balloon floats?